Hello everyone, welcome back. This is Dr. Rhonda Kofelt, and in part 8 of chapter 13 on solutions, we're going to look at some more colligative properties. We're going to start out with boiling point, freezing point. I knew what I meant. Freezing point depression, and then we'll follow that up in the next section with boiling point elevation. So the difference between the freezing point of a solution and the pure solvent is directly proportional to the molal concentrations. Remember the molal, which is moles per kilogram of solvent. Okay, the molal concentration, because it's only due to how many particles are in there, and that's what molal is going to tell us. So the freezing point of the solvent minus the freezing point of the solution is equal to the delta T, okay, what the change in the freezing point, and that is going to be equal to the molal concentration times a constant. And this is called the freezing point depression constant, K sub F, and it depends on what your solvent is. And so there's a chart usually of these, and they're going to be expressed in degrees C per molal. And so just giving you a chart, an idea of, basically normal freezing points and boiling points and what those K sub F's look like. So when we put salt on water, like when it's going to freeze overnight, what we're doing is we're depressing the freezing point so that it has to get colder in order for that water to freeze. And so by putting the salt on there, it can stay slush when it normally would have frozen at the 0 degrees C, or getting close to that. So this salt disrupts the equilibrium between the phases here. The salt particles dissolve in water, but they don't like the ice. They only like to be in the liquid portion of it, and so they kind of disrupt things. And so it will freeze slowly. The ice won't form like it normally would, and so it's going to lower that sufficiently so that everything kind of slows down enough. And what you see is then that since you've depressed the freezing point, then the weather can get colder before you'll actually see that freezing. So what does that look like when we do a calculation for it? Well, it's a super simple thing, okay? As I told you before, the freezing point depression is equal to the molal concentration times the K sub F. And so you have to look up the K sub F for these on your chart, or, if it's not on your chart, Google it. The K sub F for ethylene glycol, let's see, what am I doing? Freezing point, okay, so we're looking at water, okay, and so we're adding ethylene glycol to it. So I need the K sub F of water, which is 1.86 degrees C per molal. And I got that from a table. All right, so the freezing point depression is going to be equal to the molal concentration times K sub F. And so I've already got that information. It's 1.7 molal, which is what was given to me in the verbiage of the question. And then I'm going to multiply that by the constant. And then that's going to give me 3.2 degrees C. And that's my depression. Okay, so that's my freezing point depression. So the freezing point, okay, is going to be what that is. So freezing point, normally the freezing point of water is going to be 0 degrees Celsius. It was depressed by 3.2 degrees Celsius. So the new freezing point is going to be a negative 3.2 degrees C. So by adding antifreeze, which is what ethylene glycol is, I can lower the freezing point to 3.2 degrees below 0. So it has to get that cold before it will freeze now. And so I can adjust that by adding more antifreeze, or if I don't need that much, less antifreeze. But just whatever I need to get it to the appropriate temperature. If I know if it gets in minus 15 or whatever, we're going to have to modify it and put enough ethylene glycol in it to make sure that we are covered to minus 15 degrees C if we don't want something to freeze. So very simple calculation. Just remember that the delta T here is going to be what you are decreasing, and so you got to know that original freezing point. In water, we know it's 0, so we just assume that you know that. All right, and then here's a sucrose solution, and again, if it doesn't tell you what the liquid is, you can assume it's water. All right, and so that is very simply how you do freezing point depression.